rocks and minerals are the building blocks of our dynamic planet. They form the landscape and provide us with valuable resources. By studying rocks and minerals, we can better understand the events that shaped and continue to shape the earth. Minerals are naturally occurring chemical compounds that have been formed by geological processes. Minerals also provide chemicals that are essential for life on earth. Most rocks are mixtures of different minerals. They show remarkable variations in texture and composition depending on how they formed. Definition of rock. There are many definitions of rocks. A more acceptable scientific definition of rock is that rock is a natural occurring solid cohesive aggregate of one or more mineral or mineral materials. Minerals that form rocks. The minerals or group of minerals that commonly form rocks are as follows. Quartz. Quartz is the last mineral to crystallize, so in igneous rocks it never has any definite shapes. In rocks, it does not show flat faces. It is usually grey in igneous rocks, grey-white, yellow or red in sedimentary rocks, and grey or white in metamorphic rocks. It has a glassy or sometimes waxy look to it. Potassic feldspars group. Major minerals are microcline, orthoclase. They are pink or tan, sometimes white. They show flat, shiny faces in igneous rocks. The crystal grains are usually blocky and nearly rectangular. Plagioclase feldspars group. Major minerals are albite, labradorite, look like the potassic feldspars except they are white to dark grey, sometimes black. They may show flashes of blue or green. Mica group. Major minerals are muscovite, biotite, phlogopite. Micas have very thin layers that peel off or cleave very easily. In rocks, they are usually flakes or layers of flakes. Muscovite is silvery to brown. Biotite is black. Phlogopite is a reddish brown. Phlogopite may be found in marble. Chlorite group. Like mica, but the flakes are usually not as thin and do not peel apart as easily. The color is medium to dark green, sometimes almost black, but with a greenish tint. Hornblende. Hornblende is dark green to black. It shows nearly flat, shiny faces in almost rectangular or long, thin, needle-like crystals in rock. Hornblende is usually found in dark-colored metamorphic rocks, sometimes in igneous rocks. Actinolite and tremolite. Actinolite and tremolite are usually in long, thin blades or needle-like crystals. Actinolite is dark green, tremolite is white to grey. The crystals may be parallel to each other or spread from a point. Actinolite is usually found in schists or gneisses. Tremolite may be found in marble. Olivine group. Olivine in rocks is an olive green to greenish yellow. In rocks, it is in rounded grains. If there is much of it, it is almost sugary. It is found in dark colored igneous rocks. Calcite and dolomite. The color is usually white but can be other colors when impure. Crystal grains show flat, shiny faces often shaped like parallelograms. Calcite and dolomite are both soft. They are easily scratched with a steel point. Powdered calcite will fizz in white vinegar. Dolomite will not. The minerals are found in limestone or dolostone. The rock is dolostone and the mineral is dolomite and marble. Classification of rocks. There are three major categories of rocks: igneous, sedimentary and metamorphic. Most of the time they are simple to tell apart. They are all connected in the endless rock cycle, moving from one form to another and changing shape, texture and even chemical composition along the way. Igneous rocks form from the cooling of magma or lava and compose much of the Earth's continental crust and nearly all of the oceanic crust. Igneous rocks. Igneous rocks are formed from the molten liquid minerals that lie below the Earth's crust. They are formed from magma that cools beneath the Earth's surface or from lava that cools upon the Earth's surface. These two methods of igneous rock formation are known as intrusive and extrusive. The chemical composition of magma and its cooling rate determine the final igneous rock type. Intrusive or plutonic rocks. Intrusive igneous rocks are formed from magma that cools and solidifies deep beneath the Earth's surface. The insulating effect of the surrounding rock allows the magma to solidify very slowly. Slow cooling means the individual mineral grains have a long time to grow, so they grow to a relatively large. Intrusive rocks have a characteristically coarse grain. Extrusive or volcanic rocks. Extrusive igneous rocks are formed from magma that cools and solidifies at or near the Earth's surface. Exposure to the relatively cool temperature of the atmosphere or water makes the erupted magma solidify very quickly. Rapid cooling means the individual mineral grains have only a short time to grow, so their final is very tiny or fine grained. Sometimes the magma is quenched so rapidly that individual minerals have no time to grow. This is how volcanic glass forms. Examples of igneous rocks. Basalt is the most common type of igneous rock and it covers the ocean floor and thus exists over 2/3 of the Earth's surface. Some important igneous rocks are basalt, granite, pumice. Basalt is a very common dark colored volcanic rock composed of calcic plagioclase, usually labradorite, clinopyroxene, augite and iron ore, titaniferous magnetite. Basalt may also contain olivine, quartz, hornblende, nepheline, orthopyroxene, etc. Basalt is a volcanic equivalent of gabbro. Granite is a very common plutonic rock with feldspar and quartz as the main constituents. Granite is an igneous rock, but some high-grade metamorphic rocks are compositionally very close and have been sometimes referred to as granites also. Pumice. Pumice is a lava froth, an extremely vesicular and lightweight volcanic rock with a variable composition. Pumice is unusually lightweight for a rock. It floats in water. Sedimentary rocks. Sedimentary rocks are the second great rock class, whereas igneous rocks are born hot, sedimentary rocks are born cool at the Earth's surface, mostly under water. They usually consist of layers or strata. Hence, they are also called stratified rocks. Sedimentary rocks are formed from pre-existing rocks or pieces of once living organisms. They form from deposits that accumulate on the Earth's surface. Depending on what they are made of, sedimentary rocks fall into one of the three types. Clastic sedimentary rocks. Clastic sedimentary rocks are made up of pieces, class of pre-existing rocks. Pieces of rock are loosened by weathering, then transported to some basin or depression where sediment is trapped. If the sediment is buried deeply, it becomes compacted and cemented, forming sedimentary rock. Clastic sedimentary rocks may have particles ranging in from microscopic clay to huge boulders. Their names are based on their grain. Chemical sedimentary rocks. Chemical sedimentary rocks are formed by chemical precipitation. This process begins when the water traveling through rock dissolves some of the minerals, carrying them away from their source. Eventually, these minerals are redeposited when the water evaporates away or when the water becomes oversaturated. Biologic or organic sedimentary rocks. Biologic sedimentary rocks form from once living organisms. They may form from accumulated carbon-rich plant material or from deposits of animal shells. Another type of sediment actually arises in the sea as microscopic organisms known as planktons. Dead plankton steadily shower their dust shells onto the seafloor where they accumulate in thick layers. That material turns to two more rock types, limestone or carbonate and chert or silica. Another type of sediment forms where dead plant material builds up into thick layers. With a small degree of compaction, this becomes peat. After much longer and deeper burial, it becomes coal. Coal and peat are organic in both the geological and the chemical sense. Approximately 3/4 of the Earth's bedrock on the continents is sedimentary. The most common set of sedimentary rocks consists of granular materials that occur in sediment. Sediment mostly consists of surface minerals, quartz and clays that are made by the physical breakdown and chemical alteration of rocks. Sediment may also include pieces of stones and shells and other objects, not just grains of pure minerals. Sand and mud are carried down rivers to the sea, mostly. Sand is made of quartz and mud is made of clay minerals. As these sediments are steadily buried over geologic time, they get packed together under pressure and low heat, not much more than 10 degrees Celsius. Examples of sedimentary rocks. Some of the important sedimentary rocks are bauxite, chalk, coal, gypsum, laterite, sandstone. Bauxite is an aluminium-rich sedimentary rock. It is a principal ore of aluminium. Chalk is a soft, friable, porous variety of limestone. The best known chalks are of Cretaceous age. Coal is a combustible rock containing more than 50% by weight of carbonaceous material. Coal in most cases is a lithified peat. Gypsum as a rock type is an aggregate of gypsum crystals. Gypsum is an important industrial material. It is used mostly in the construction industry. Laterite is a reddish weathering product of mostly basaltic rocks. Metamorphic rocks. Metamorphic rock, which comes from the Greek word to change form, is formed by applying great pressure and temperature to existing rock, converting it into a new distinct type of rock. Igneous rocks, sedimentary rocks and even other metamorphic rocks can be modified into metamorphic rocks. Metamorphic rocks are harder than other types of rocks, so they are more resistant to weathering and erosion. Rock always converts into the same type of metamorphic rock. For example, the sedimentary rocks, limestone and shale, become marble and slate respectively when metamorphosed. Foliated metamorphic rocks. Foliation forms when pressure squeezes the flat or elongate minerals within a rock so they become aligned. These rocks develop a platy or sheet-like structure that reflects the direction that pressure was applied. Non-foliated metamorphic rocks. Non-foliated metamorphic rocks do not have a platy or sheet-like structure. There are several ways that non-foliated rocks can be produced. Some rocks, such as the limestone, are made of minerals that are not flat or elongate. No matter how much pressure you apply, the grains will not align. Another type of metamorphism, contact metamorphism, occurs when hot igneous rock intrudes into some pre-existing rock. The pre-existing rock is essentially baked by the heat, changing the mineral structure of the rock without addition of pressure. Metamorphic phases. As metamorphic rocks change under heat and pressure, their ingredients recombine into new minerals that are suited to the conditions. The concept of metamorphic phases is a systematic way to look at the mineral assemblages in rocks and determine a potential range of pressure and temperature conditions that were present when they were formed. The definition of the term metamorphic phases is a group of rocks characterized by a definite set of minerals at perfect equilibrium. There are 7 widely recognized metamorphic phases ranging from the zeolite phases at low pressure and temperature to eclogite at very high pressure and temperature. A metamorphic phase is the set of minerals found in a rock of a given composition. That mineral suit is taken as a sign of the pressure and temperature that made it. The 7 metamorphic phases are zeolite phases, prehnite pumpelite phases, green schist phases, amphibolite phases, granulite phases, blue schist phases, eclogite phases. It should be noted that metamorphic phases are different from sedimentary phases, which include the environmental conditions present during deposition. Sedimentary phases can further be divided into lithophases, which focus on a rock's physical characteristics, and biophases, which focus on the paleontological attributes or fossils. Examples of metamorphic rocks: gneiss, marble, quartzite, slate and soapstone. Gneiss is a banded, coarse-grained metamorphic rock that formed deep in the crust beneath forming mountain ranges. Most gneiss rocks are granitic. Marble is mostly composed of calcium carbonate. Quartzite is consisting largely or entirely of quartz. Majority of cases, quartzite is a metamorphosed sandstone. Soapstone is a soft rock composed of talc or other silicates. Soapstone is so named because of slippery feel when touched. Rock cycle. The rock cycle is a group of changes. Igneous rocks can change into sedimentary rock or into metamorphic rock. Sedimentary rock can change into metamorphic rock or into igneous rock. Metamorphic rock can change into igneous or sedimentary rock. Igneous rock forms when magma cools and makes crystals. Some of the features of rock cycle are: all three rock types can be turned into metamorphic rocks. All three types can also be changed through the rock cycle. All rocks can be weathered and eroded into sediments, which can then form sedimentary rock. Rocks can also be completely melted into magma and become igneous rock. Igneous rock can be metamorphosed directly into metamorphic rock, and metamorphic rock can be directly to sediment. However, sedimentary rocks cannot melt directly into magma without being metamorphosed along the way. A rock belonging to any of the three rock types can stay where it is and not move around the cycle at all for a long time. Rocks aren't the only important parts of the cycle. They have two intermediate materials in the rock cycle, magma and sediment. Each of the five materials of the rock cycle is defined by the one process that makes it. Melting makes magma. Solidification makes igneous rocks. Erosion makes sediment. Lithification makes sedimentary rock. Metamorphism makes metamorphic rock. But most of these materials can be destroyed in more than one way. All three rocks can be eroded and metamorphosed. Igneous and metamorphic rocks can also be melted. Magma can only solidify and sediment can only lithify. Rock cycle terminology is a misnomer because there is no overall direction to the cycle. With time and tectonics, the material of Earth's surface moves back and forth in no particular pattern. That is why the process is not a cycle. It can be termed as rock transformation process. Mineral hardness. Rock hardness is the ability of the mineral to resist being scratched. A mineral can scratch any mineral softer than itself, but can be scratched by another mineral that is harder. Scratch tests are often done with common objects. Mohs hardness scale. It is a scale of 1 to 10 ranked from the softest talc to the hardest diamond. The Mohs scale of minerals hardness characterizes the scratch resistance of various minerals through the ability of a harder material to scratch a softer material. It was created in 1812 by the German geologist and mineralogist Friedrich Mohs. It is one of the several definitions of hardness in material science. Hardness is the resistance of a material to being scratched. The test is conducted by placing a sharp point of one specimen on an unmarked surface of another specimen and attempting to produce a scratch. Here are the 4 situations that one might observe when comparing the hardness of 2 specimens. If specimen A can scratch specimen B, then specimen A is harder than specimen B. If specimen A does not scratch specimen B, then specimen B is harder than specimen A. If the 2 specimens are equal in hardness, then they will be relatively ineffective at scratching one another. Small scratches might be produced, or it might be difficult to determine if a scratch was produced. If specimen A can be scratched by specimen B, but it cannot be scratched by specimen C, then the hardness of specimen A is between the hardness of specimen B and specimen C. Summary. Definition of rocks is that a rock is a natural occurring solid cohesive aggregate of one or more mineral or mineral materials. There are three major categories of rocks: igneous, sedimentary and metamorphic. Most of the time they are simple to tell apart. They are all connected in the endless rock cycle, moving from one form to another, changing shape, texture and even chemical composition along the way. Igneous rocks are formed when magma or molten rocks have cooled down and solidified. Sedimentary rocks are formed by the accumulation of other eroded substances, while metamorphic rocks are formed when rocks change their original shape and form due to intense heat or pressure. Igneous rocks are commonly found inside the Earth's crust or mantle, while sedimentary rocks are found in water bodies, sea, ocean, etc. Metamorphic rocks are found on the Earth's surface. Igneous rocks can be an important source of minerals, and sedimentary rocks or their bedding structure is mostly used in civil engineering for the construction of housing, roads, tunnels, canals, etc. Geologists study the geological properties of metamorphic rocks as their crystalline nature provides valuable information about the temperatures and pressures within the earth crust. Examples of igneous rocks include granite and basalt, while examples of sedimentary rocks include shale, limestone and sandstone. Common examples of metamorphic rocks are marble, slate and quartzite. The rock cycle is a group of changes. Igneous rocks can change into sedimentary rock or into metamorphic rock. Sedimentary rock can change into metamorphic rock or into igneous rock. Metamorphic rock can change into igneous or sedimentary rock. Igneous rock forms when magma cools and makes crystals. Mohs hardness scale of 1 to 10 ranked from softest talc to hardest diamond. The Mohs scale of mineral hardness characterizes the scratch resistance of various minerals through the ability of a harder material to scratch a softer material.